First thing I want you to see is this terminology right here at the beginning of this section. A function whose graph is a line is a linear function. That's kind of intuitive. You can represent a linear function with a linear equation. Y equals 3x plus 2 is the example that they have given us, and it's also the one that is graphed here. Y equals 3x plus 2. The y-intercept being 0, 2. What is the slope here? 3, jogging from our memories from geometry here. The value of y depends on x, so y is called the dependent variable and x is called the independent variable. So the input, the x input is the independent variable, the output, the y, is the dependent variable. The first thing we're going to do is we are going to recall how to graph linear equations. The first way we are going to graph is using slope-intercept form, okay? Slope-intercept form. Now, they do some graphing here with just picking points, but we're not really going to pick points here. It's faster if it's already in slope-intercept to graph it that way. So look at the first example. They want us to graph this equation. If you will recall, slope-intercept is y equals mx plus b. B is your y-intercept. M is the number in front of your x, which represents your slope. Your slope tells you your movement. Your numerator tells you your up and down or your y movement. Your denominator tells you your left and right or your x movement. So we're going to start at our y-intercept. What is my y-intercept here?
3.
It is 3, all right? Positive 3 on the y-axis is where I'm going to start. That's going to be my first point here, all right? I'm going to move 2/3 in the positive direction. So how is that going to move me? 2/3. How do I move?
Over 3, up 2.
Right, so up 2 and right 3. Up 2 and right 3. So I'm going to take this. I'm going to go up 1, 2, right 1, 2, 3. So my next point is going to be right here. Up 2 over 3. Once I have those 2 points, what do? Draw a line, right? That's pretty straightforward. You just connect those dots and you have your line that represents your linear equation, all right? Arrows at the end because that tells me it goes on infinitely. That is my graph, all right? That is my graph. So I want you to try some of these just to jog your memory on graphing. Top of page 63, we are going to graph those 3 lines. Well, if it will let me go there.
Do you have more graph paper?
For this first one, the y-intercept we're very familiar with because that's what we use to graph. The y-intercept is where it crosses the y-axis. The x-intercept then is where it crosses the x-axis. That actually second one, B, you could have done with intercepts. You could have done your x-intercepts and your y-intercepts. What you'll notice about your intercept is whichever one you're talking about, the other one is 0. So when I'm talking about my y-intercept, my x is 0. When I'm talking about my x-intercept, my y is 0. And that's how you actually find them. If you have an equation and you want to find an intercept, make the other guy 0 and then solve, and that is your intercept. That's where it crosses. When things are in standard form, it's usually easier to graph using intercepts. You can always move it to slope-intercept form if you want to, but if it's already in standard form, it's often easier to graph with intercepts, especially if you're talking about a word problem. Because very often word problems are using different units. So for example, they'll say, you know, number of seats per bus or whatever. And so it's not going to correspond one-to-one when you do a graph. And so then all of a sudden you'll be graphing like, you know, a y-intercept of 22 and a slope of 2. And then this is going to be really hard to do on this little tiny graph. And so sometimes it's easier to do it in standard form and just use your x and your y-intercepts to graph. But this is standard form. Ax plus by equals c. So instead of having y equals mx plus b, your y on one side, your x and your constant on the other, for standard form, you have your x and y on one side, your constant on the other. Let's look at the example that they give us here. The equation 3x plus 2y equals 120 models the number of passengers who can sit in a train car, where x is the number of adults and y is the number of children. Graph the equation, describe the domain and range, and explain the x and y intercepts, what they represent. All right, so when I do this graph, I am not going to do 1, 2, 3, 4, right? Because I know that I have this 120. Okay, and so the first thing you want to do is kind of figure out what your x and y intercepts are and then decide how you're going to set up this graph. All right, what's the most logical way to do this? So when I'm solving for my intercepts, I have this 3x plus 2y equals 120. If I want to solve for my x-intercept, I want to make my y 0. Well, if I make my y 0, I simply have 3x equals 120. So how do I solve for what my x is here? Divide by 3. So what is x? 40. So my x-intercept is going to be 40, 0. All right. Let's look at y-intercept. If I am solving for my y-intercept, I want to make this x 0. So I end up with just 2y equals 120. What is my y here? 60. So my y-intercept is going to be 0, 60. So instead of doing by ones, what's a better way to probably do this? Instead of ones, I would probably use what? Tens. Yeah, I would use tens here because it's going to make my life a little easier. So I'm going to say 10, 20, 30, 40, 50, 60, right? I'm going to make those tens. That's more logical. All right. And so then when I go to graph these, I don't have to worry about ones, twos, and threes and counting up to 60. All right. So I'm just going to put the intercepts where they belong. I'm going to put my y-intercept at 0, 60, which is going to be right here. And I'm going to put my x-intercept at 40, 0, which is right here. All right. And then I'm going to connect these two dots for my graph. Now, what do you notice about the quadrants here? What am I missing? This is not a full coordinate plane. It's just one quadrant. Why do you think that is? My x and y's represent people. I can't have negative people. That doesn't make sense. Okay, so in this word problem, there's no need to graph it past the first quadrant. All right, so let's talk about what my x and y intercepts mean. If I have 40 x's and 0 y's in the word problem, what does that represent? 40 x's and 0 y's. What does that represent in the word problem? What do my x's and y's represent? X's are number of adults. Y's are number of children. So I have 40 x's and 0 y's. What does that intercept represent?
40 adults and no children.
How many it can hold with no children? How many adults can this hold with no children, right? Not that I would want to be on the train car, but what does 0, 60 represent? Right, 60 children with no adults. Doesn't sound like a great train car, but that's what it represents. So it's important that when you're doing a word problem, you comprehend what your answer represents. If not, then sometimes your answer cannot make sense and you didn't think about it because you didn't know what you were talking about, right? If you had said, oh, my intercept's negative 20, and you were talking about the number of children, you did something wrong. You desperately did something wrong here, right? And so it's important that in your mind, you have an idea of what you're talking about so that if you make a mistake, your logic kicks in and says, I probably wouldn't have negative 20 children. So I probably did something wrong. And so that's why they want you to interpret this. They want you to know. So then if I were to shade this region right here, what do you think this region would represent?
Max capacity.
Right, all my combinations. The line would be the max capacity, right, of my combinations, and that shade would represent all the possible combination of kids and adults I could have on this train car. All right, make sense? All right, so try it. All right, what were your intercepts for this one? They were both 40, right? So both of these were 40 here. Then they want you to explain. So your graph should have looked something like this. How molded seats change the number of seated passengers? Why did that affect? On the just bench seats, you can squish several kids in there, right? But when they're molded seats, then it's just the number of people that fit in that seat, period. It doesn't matter if they're small or big. It's not going to hold a different number of seats. Slope is vertical change over horizontal change. It's also called rise over run. You're changing Y's over your change in X's, all right? You're seeing how far up you go compared to how far over you go. The formula itself, vertical change over horizontal change, is actually Y2 minus Y1 over X2 minus X1. Hopefully this is firmly planted in your brains from last year. There are regulations in building codes as to what slopes can be for stairs in houses. There are building codes for what ramps for wheelchairs can be. Why do you think there would be codes regarding slopes of ramps or stairs? Want a small slope to push grandma down on her wheelchair, right? We do not want a really steep slope. For stairs, it's actually dangerous if the width of the stair is too small compared to the height of the stairs, because you will tumble down a set of stairs if the slope is off. And so we have codes what the rise over run has to be. All right, so this is used lots of places. I mean, an architect all the time, right? This is used lots of places. It's used in, art everywhere. They look at slopes and how it affects the visual appeal of the eye as well as the practical use of what you're building. All right. Just in math, we do it for linear equations. We do it for lines. We look and see if it's a positive slope, it's going up. Is it a negative slope? It's going down. How steep is the slope? And so the way you calculate it is you simply subtract your y's divided by subtracting your x's. You typically leave slope in a fraction form, all right, in a fraction form. So with this example, find the slope of the line through the points 3, 2 and negative 9, 6. Very, very simple. I'm going to take my x's, 2 and 6. It does not matter which order you start in. If I say 2 minus 6 or 6 minus 2, it doesn't matter. What matters is that the denominator matches the numerator, okay? So if I say 2 minus 6 here for the y, then I must say 3 minus a negative 9 for the x. If I were to say 6 minus 2 for the y, then I must say negative 9 minus 3 for the x, okay? So it doesn't matter which order you start, it matters that they match. All right, what is 2 minus 6? Negative 4. What is 3 minus a negative 9?
12.
Positive 12, it reduces to negative 1/3, all right? And you'll see over here, 6 minus 2 is 4, negative 9 minus 3 is negative 12. You get the same answer. That slope is negative 1/3. When you are graphing, make sure that if you are giving me the slope of a graph, your negatives and positives match what's going on. A negative slope will go down from left to right. A positive will go up from left to right. Question. All right, first one, what you get? 2/3. What about the second one? Negative 6/7. How do we do? Anybody need to see it? Good. All right, point slope form. So we're going to introduce multiple forms of a line. Standard form was ax plus by equals c. Point slope. You use this like a million times when you're doing these linear equations. This is always going to be used when you have, shockingly, a point and the slope, right? Okay, so point slope, that's when you're going to use it. When you have a point and the slope, you're going to start with point slope. Even if it wants it in standard form or slope intercept or whatever, you're going to start with this. It comes from your slope equation. So your slope equation is m, that's what represents slope, y2 minus y1 over x2 minus x1, all right? If you multiply this group over, you get this equation, all right? So this equation is y minus y1 equals m times x minus x1. Y minus y1 equals m times x minus x1. All right? Your y's and your x's will always stay y and x. They will be variables. Your m, your x1, and your y1 should be filled in with numbers. All right? So it says write in standard form an equation of the line with a slope -1/2 through the point 8, -1. 8, -1. Okay, so they've given me the slope and they've given me a point, but they want standard form. I cannot get standard form from point and slope. I can get point slope. And then I can distribute, move my x's and y's, move my constants, and I can get it in standard form. All right? So that's what I'm going to do. I'm going to start with my point slope. My slope here, that's my m. My point, that's my x1 and my y1. And then I'm just going to fill it in. Y minus y1 equals m x minus x1. All right, how do I get it now in standard form? What do I need to do? I simplify this side, which is what? Just y plus 1. What about on the right side? Distribute, right? So -1/2 x, +4. All right? Now, standard form. Standard form is ax plus by equals c. What do I need to do? Yeah, let's get this guy over here. And then let's move this over here, right? Cancels there, cancels there. I have 1/2 x plus y on this side, and I have 3 on that side. I will tell you, most of your standard form, and your book did not actually do this, but most of your standard form will get rid of fractions. So if you have a standardized test and they ask for standard form, more likely than not, it will not have any fractions in it. And your x won't be negative. That's just typically when you see it on like a standardized type thing. So I want to show you how to do this because I want you to understand how to get it in standard form if you were to do like a multiple choice question here. To get rid of this denominator, what can I do? Get rid of that fraction. Multiply everything by your common denominator. So I'm going to multiply this by 2, this by 2, and this by 2. So I would have x plus 2y equals 6. That's the same equation as 1/2 x plus y equals 3. Same equation. But you need to know how to recognize that. So if you're doing a standardized test, or if I say I want it in standard form with no fractions, right? Most of your standard forms will get rid of fractions altogether, meaning your A, your B, and your C will be whole numbers or integers rather, okay? So make sure you recognize that because I think all of your answer keys for me are in standard form without fractions. No fractions, and typically your x won't be negative. Typically, it won't be negative. So go ahead and try A and B there, A and B, and I actually do want you to get rid of your fractions here. So for A and B. But here they say they want the point slope, and they've given us 2 points, 1, 5, and 4, -1. And so in order to write point slope, I have to have the slope. And so when you're given 2 points and you need to then convert to an equation, the first thing you're going to do is find the slope. And then you're going to use point slope, and then you're going to see, do they want it in some other form, okay? So I am going to first find my slope. So I'll say y minus y over x minus x, all right? When I do this, I am going to get what slope here? Yeah, so 5 minus the -1 is 1 minus 4 is -3. My slope here is -2, all right? They ask for point slope. I can actually use either point, and this a valid point slope, right? I can say y minus y1 equals m times x minus x1, or I can say y minus y1 equals mx minus x1. Okay, both of those are valid point slope equations for that line. And I will say, if I were then to solve for either standard or slope intercept, I would get the same exact standard or slope intercept here based on this because it's the same line. But either one of those works for point slope. Point slope on a line has an infinite number of possibilities because it has an infinite number of points you could use with that slope. All right, so either one of those will work. For the A, B, and C here, just use your first one. Use your first point as your point slope so that we all have the same answer. All right, so go ahead and try A, B, and C. And then we're going to do slope intercept. What was your slope for your first one? -1/4. So y minus 0 equals -1/4 x minus 5. What was your slope for your second one? -9/4. Y plus 1 equals -9/4 x plus 2. And your slope for your last one? 4/9. Y minus 1 equals 4/9 x minus 5. How'd we do? So this is the most common form that you're going to see. This is the one you typically graph from, just a standard graphing. Y equals mx plus b. M is the slope. B is the y-intercept. Pay attention to the fact that it has to be in this form for the coefficient of x to be your slope. So they've given us this example, and this is in standard form. And very often they'll say, what's the slope? And I'll have people say 4. And that's not true. It is not the coefficient of x when it is in standard form. It is only the coefficient of x when it is in slope-intercept form, okay? And so you have to be careful that you don't just assume the number in front of x is your slope. That is only for this particular form. So find the slope then. The easiest way to find the slope, if you have a form of a line, is to put it in slope-intercept. And so to put it in slope-intercept, you're going to move your x over, and you're going to divide by whatever's in front of your y. So we're going to have 3y equals -4x plus 7. Remember, when you do it, you have to divide absolutely everything by that. So I have y equals -4/3 x plus 7/3. My y-intercept here would be 7/3. My slope here would be -4/3. -4/3. So let's look at these. What would my slope then be for this first one? What's an easy way to think about this? Negate your coefficient of your x. What is that? -3. Divide by what's in front of your y. +2. Right? So -3/2 would be my slope. So if it's there, then do it. Look at the fraction one. What am I going to do with a fraction? Negate what's in front of my x. What is that? -2/3. Divide by what's in front of my y. You think I'm going to leave it that way? Yeah, keep change flip. -2/3 times 2/1. -4/3. All right? See what we're doing here? So then, what is my slope of this one? If it's in standard form, what is my slope? -a/b. Your coefficient of your x should be negated, divided by your coefficient of your y when you're going from standard form to slope-intercept. All right? Easy enough? Let's look at types of equations then. They have summarized it. On page 66, in the middle of the page, they have summarized the same line 3 different ways. All right? Point slope, y minus 2 equals -3 x plus 4. The same line in standard form, 3x plus y equals negative 10. The same line in slope-intercept form, y equals negative 3x minus 10. All three of these equations represent the same exact line, but just three different ways. You can gather different things from different lines. I could graph from this line. I have a point. My point is negative 4, 2, right? It's opposite. Negative 4, 2. My slope is negative 3. So I could start at that point and move down 3 and over 1. Here, I can graph by intercepts. 0 out my y, my x-intercept is negative 10 thirds. 0 out my x, my y-intercept is negative 10. I can graph those two, and I have the graph. Here, slope-intercept. Start at negative 10, go down 3 and over 1. So you can graph from all three of these, just depending on which way you're graphing. Okay? Look at the types of lines you can have. These are special cases here. All of these are special cases. Horizontal line. What is my slope of a horizontal line?
0.
0, right? It does not go up. So my numerator is 0 here. So it doesn't really matter what's happening in my denominator. My numerator is 0. What about my vertical line? X equals a number.
Undefined.
Yeah, because my denominator is going to be 0 here. This is undefined. Perpendicular lines, special case. Negative reciprocals of each other, okay? So if this has a slope of, let's say, negative 1/2, this is going to have a slope of positive 2, all right? Perpendicular lines are negative reciprocals of each other when it comes to slope, all right? The way they define this is they multiply the slopes, you get negative 1. Negative 1/2 times 2 is negative 1. They are negative reciprocals of each other. Parallel lines. What type of slopes do parallel lines have? The same, all right? So if this slope here is, let's say, 2, this one is also going to be 2, okay? Same slope. So horizontal lines are 0, vertical undefined. Perpendicular, they're negative reciprocals of each other. Parallel, they are equivalent. Those are your 4 types of special cases when it comes to slopes. If you just have 2 lines with different slopes, they're just going to be intersecting. They're not going to be a special case, okay? They will often ask this with perpendicular and parallel. Write an equation of a line through each point and perpendicular to this particular line, all right? So if they have told me it is perpendicular to a line, what have they ultimately given me? What have they given me? The slope, all right? What's the slope of this line that they gave me? What's the slope of this guy? The slope of this one is just 3/4, right? So if I want one that is perpendicular to it, then I am going to flip this and negate it, okay? They did not tell me what type of equation they wanted. 0, 4. What did they give me there? Yeah, they give me a point, but what point did they give me? 0, 4. My x is 0, right? Y-intercept, okay? So I have slope and my y-intercept. What's probably the best equation to write it in here? Yeah, y equals mx plus b. I'm there, okay? For this one, I have just a point, all right? Just a point. So I'm going to have to start with point slope, and then your instructions will usually tell you what type of equation. For this one, they actually want slope-intercept, all right? I do not have my intercept. I have my point and my slope. So I have to start here. Y minus y1 equals m x minus x1. They want it in slope-intercept form. So how do I get it in slope-intercept form? Y equals mx plus b. Distribute this guy. Y minus 1 equals negative 4/3 x. What is negative 4/3 times negative 6? Right, and I can reduce it to 8. Yeah, so it ends up being 2 times 4 there. All right? I'm not done. Slope-intercept, what do I need to do? Add my 1. So when they say perpendicular or parallel, the only thing that you need from the line that they gave you is the slope. And if it's perpendicular, you're going to do negative reciprocal. If it is parallel, you're just going to use that slope. Okay? So try one and we are done. All right, so check your work on these. The first one was perpendicular. You should have used negative 1/5. Parallel, positive 2/3. Really quickly, a vertical line through this. Vertical is x equals something. What is x equal here? What is x? X is 5. A vertical line through that would be right here at x equals 5. Horizontal line. Where would a horizontal line be through this? At -3. It's y equals a number.